Okay, students. So now the topic is pair of linear equations in two variables. Okay, this is a new chapter. Pair of linear equations in two variables. So before that, we are discussing about the linear polynomials. Linear polynomials. It is the linear equations. So these equations are to be forming from the linear polynomials. So what is the definition of the linear polynomial first? Linear polynomial. Linear polynomial. So already we learned about the polynomial. Okay, so the algebraic equations. In an algebraic equations, the exponent of the variables are non-negative integral powers. The exponents of the variables are non-negative integral powers. Then that algebraic expression is called as a polynomial. Then that algebraic expression is called as a polynomial. So the polynomial means, for example, we are taking an algebraic equations x square plus y cube plus xy plus 3y. So it is an algebraic equation and also it is called as a polynomial. We are observing the exponents of the variable. In each term, exponent of the variable. What is the exponent of this variable? 2. Here the variable is y, the exponent is to be 3. Here the variable is x and y. The exponents of x is 1, y is 1. Here the term is to be 3y. 3 is a constant term, y is a variable. The exponent of the variable is to be 1. Is there any negative term? No. Then automatically this algebraic equation is called as a polynomial. This algebraic equation is called as a polynomial. In the exponents of the variable are negative integer, the meaning of the thing -2 or whatever it is, root 3 by 2, like that. For example, we are taking the other than the polynomials. So x to the power of -5 plus 3 z minus root 7y. It is not a polynomial. Why? Because in this expression we have the three different variables. One is x, one is z, one is y. The exponent of the variable y is 1. It is a positive integer, no problem at all. Here the variable is to be z. It is also having the positive exponent in the integer place. Here the variable is x, but the exponent of the variable is to be non-negative integer. It is to be a negative integer. It is to be a negative integer. So you can't say the thing it is to be a polynomial. Just it is an algebraic expression. Okay, and one more. 3 by 2 plus 1 by y minus 9 by 7 x. Okay, so it is a one more example which is not a polynomial. You can observe the expression. In each term we have one variable. It is x, it is y, it is x. Here the variable x has some exponent which is not an integer and it is a positive, no doubt of it, it is. So x to the power of 3 by 2. 3 by 2 is a positive value, but it is not an integer. What is it? The polynomial definition. The exponents of the variables are non-negative integral powers. Integers. Integers. First of all, it is not an integer. Okay, it is not an integer. Here it is a negative integer, so it is not a polynomial. It is not an integer, then automatically it is not a polynomial. Okay, so we can observe the second term, 1 by y. 1 by y. What is the exponent of y in the place? 1. So to be moving towards to the numerator, then y to the power of -1. Already we have one formula, 1 by a to the power of n is equal to a to the power of -n. Like that, 1 by y to the power of 1 is equal to y to the power of -1. What is the exponent of that variable here? -1. Then automatically it is a negative integer. Okay, then coming to here, variable x, integer is to be positive. So what I said, each variable has exponent which is non-negative integer, okay, but here it is not an integer, it is a negative integer, it is only positive integer, whatever it is. So it is not a polynomial, each variable has non-negative integer as an exponent. Okay, so the next, it is a polynomial. Then coming to the linear polynomial, the polynomials are some types. It is a which is called as a linear polynomial. We'll discuss about that. So the exponent of the variable, the degree of the variable is to be 1. The degree of the variable is to be 1. What is the meaning of the degree of the variable? The meaning of the thing here. So it is the first term, is the second term, is the third term, it is a fourth term here. The first term exponent is to be 2, the second term exponent is to be 3, the third term exponent is to be 1 plus 1 here. Here we again add both the term where exponents, it is a 2. So the fourth term exponent is to be 1. Which is the highest exponent in each in the terms? Which is the highest exponent in the terms in that expression is called as the degree of the polynomial. Is called as the degree of the polynomial. Which is the highest exponent here? 3 is the highest exponent. Then automatically 3 is the degree of the polynomial. 3 is the degree of the polynomial. We are taking one more example here. X, Y, Z. It is also to be a polynomial. Why? Because the exponents of the variables are to be only positive integers. 1, 1, 1. Clear? Then the degree of this polynomial is to be add those 3 exponents. 1 plus 1 plus 1. That is equal to 3 here also. Now we are taking that x plus y square plus x to the power of 5. So they have some coefficients, no doubt of it is x6, whatever it is, 5 root 3. Okay, the coefficients are to be real numbers. The coefficients of the variables are to be real numbers. Okay, so it is a positive 1, it is a positive 2, it is a positive 5, no problem. Then the highest exponent in this expression is to be a 5. Then automatically the degree of the polynomial is to be 5. Then coming to here, linear polynomial. Linear polynomial. The degree of the linear polynomial is always to be a 1. A polynomial which has degree is 1. A polynomial which has degree is 1. Then it is called as a linear polynomial. So I am taking that x plus y. What it is? What is the degree of this? Here it is 1, here it is 1. Then highest exponent is to be 1 only. Okay. X plus y plus z. What is the highest exponent of the variables? 1 only. Then automatically it is also to be a linear polynomial, whatever it is. A plus b plus c plus d. So different variables are to be there. In each term the exponent is to be 1, 1, 1, 1. Then which is the highest exponent? 1. Then automatically it is also to be a linear polynomial. Okay. So the degree of a polynomial is 1, then it is called as a linear polynomial. Okay. Then coming to that linear polynomial. Now we are discussing about the linear equation, which is called as an equation. So all these polynomials are to be expressions only. We can say that those are to be expressions. Algebraic expression, these are also to be algebraic expressions which are not to be a polynomials. Okay, so all these are expressions. Okay, the expression is equalized with any constant value. Then automatically that is called as an equation. For example, x plus y is equalized with any constant value, whatever it is 3. Okay, here it is to be minus 7, whatever it is. A plus b plus c plus d is equal to root 5. Then it is equalized with the constant value 3, it is equalized with the constant value minus 7, it is equalized with the constant value 5. We are taking one more polynomial, x plus 7 is equal to 0. It is also to be a linear polynomial. All these are to be linear equations. Equations means the expression is equalized with any constant. The expression which has a sign is to be equal. Then automatically those expressions are said to be equations. There is no equal to symbol here. Then automatically just it is an expression. Okay, clear what I said? Okay, then all these are said to be linear polynomials. Okay, then linear equations. Okay, then coming to this linear equations, it is clear. Now we are continue the topic. Linear equations in two variables. Linear equations in two variables. Linear equations in two variables means, here we can observe that here we have the two, it is a linear equation. What I said, x plus y is equal to 3, linear equation. X plus y plus z is equal to minus 7, it is a linear equation. A plus b plus c plus d is equal to root 5, it is a linear equation. X plus 7 is equal to 0. All these are to be linear equations. So but in this linear equations we have two variables, 1, 2. How many variables are to be there? 2. Here 1, 2, 3. 3 variables are here. 1, 2, 3, 4. 4 variables are here. Here only one variable is to be here. a linear equation which has only one variable, that is called as a linear equation in one variable. A linear equation which has only one variable, it is called as a linear equation in one variable. Linear equation in two variables, linear equation in three variables, linear equation in four variables. Clear what I said? It has only one, so we call it linear equation in one variable, linear equation in two variable, linear equation in three variable, linear equation in four variables. Clear? So here these are to be variables a, b, c, d. Okay, so now we are taking one more example. Ax plus by is equal to c. No doubt it is a linear equation where x and y are variables, a, b, c are belonging to the real numbers. A, b, c are belonging to the real numbers. The meaning of the thing, in the places of a, b, c we are keeping any real number. So for example, you can substitute the real number 3x minus root 8y is equal to 9. Now it is a polynomial linear equation. So in the places of a we are substituting 3, in the place of b we are substituting minus root 8, in the place of c we are substituting 9. So the degree of the variable is to be 1, 1. Then automatically it is a linear equation. Linear equation with how many variables? 1 and 2. 2 variables. Clear? So linear equation in 2 variables. Okay. So linear equations in 2 variables. So the general form of the linear equation in two variables is ax plus by plus c is equal to 0, where a, b, c belonging to the real number. A, b, c belonging to the real number, and a is not equal to 0, b is also not to be equal to 0. What is that? A is not equal to 0 and b is not equal to 0. If a is equal to 0, then automatically 0 into x is equal to 0. Then what is the balance in the case? By plus c. How many variables are to be there? Just only one variable. Then automatically it is to be changed as a linear equation in one variable. Linear equation in one variable. Instead of a, b is equal to 0, what will happen? Ax plus c is equal to 0. Then how many variables are there? Only one, that is to be x. Okay, a, c are to be constant values. Already I said in that a, b, c are belonging to the numbers. Then b is equal to 0, then ac is equal to 0, then automatically it is also to be a linear equation in one variable. So a, b both are to be equal to zeros, then c is equal to 0. Constant value is not equal to, okay, a, b both are to be zeros, then c is equal to 0 is to be balanced. C means it is a constant. 7 is not equal to 0, 2 is not equal to 0, 3 is not equal to 0. Okay, c is equal to 0 means c is also to be 0 in the case. C is also to be 0 in the case. That is the meaning of the thing. Okay, so ax plus by plus c is equal to 0, where a comma b comma c r belongs to R. It is the general form of the linear equation in two variables. Linear equations in two variables. Now coming to that, pair of linear equations in two variables. So pair, already we know what is the meaning of pair. We are observing the two, that is called as a pair. Okay, so the meaning of a thing, linear equations in two variables, pair. Okay, the meaning of thing, the general form of the first equation is to be ax plus by plus c is equal to 0. Okay, it is the linear equations in two variables. One more equation we can observe. The meaning of a thing, here a, b, c are constant values. So you can say that it is the first equation x coefficient, b1, a1, it's a b1. First equation y coefficient, first equation constant value. Then coming to the pair, means one more equation, a2x plus b2y plus c2 is equal to 0. a2x plus b2y plus c2 is equal to 0. The meaning of a thing. Here at the second equation, it is the second equation, x coefficient a2, y coefficient b2, c2 is a constant value. Means these are to be different values, a1, b1, c1, a2, b2, c2. All those are to be belonging to the real numbers. Okay, so then these are said to be pair of linear equations in two variables. a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. The condition is here a1 square plus b1 square is not equal to 0. The condition is here a1 square, okay, sorry, Is it? A1 square plus B1 square is not equal to 0, and A2 square plus B2 square is also not equal to 0. The meaning of a thing, for example, which is satisfied with this equation, 3x plus 4y plus 6 is equal to 0 is the first equation. We can observe that it is a, it is b. A1 square is 3, a1 is 3, 3 square means 9, plus b is 4, b1 is 4, 4 square is 16, 16 plus 9 is 25. The result is not equal to 0. Okay, the result is not equal to 0. So for example, one more equation, 3x minus 3y plus 6 is equal to 0. We can observe the thing. A is 3. 3 square means 9. B is minus 3. B is minus 3. So minus 3 whole square means, what you said? Minus 3 whole square means 9. 9 plus 9 is equal to 18. So that is also not to be equal to 0. Okay, what we are taking the condition, a1 square plus b1 square is not equal to 0. The first equation. The second equation is also to be same. A2 square plus b2 square is also not equal to 0. These are the conditions for this pair of linear equations in two variables. A1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. Okay.